Hello ma'am and friends, thank you for the opportunity. My name is Lomboan from Group 3. Now I will present my group assignment with the title 7 Water Pollution. Water pollution refers to the introduction of a substance to the environment, use of a resource, or degradation of the health of humans, wildlife, or ecosystem. Pollution may be caused by point sources at stationary locations such as an effluent pipe or non-point sources, also called diffuse sources, such as land runoff and the atmosphere. The mass flow of a pollutant is expressed as a load in mass per unit time. 7.1 Main pollutant. Organic waste. Organic matter in water are composed of organic compounds. Generally, most carbon-containing compounds are organic, excluding steel and simple oxides of carbon. Organic compounds include natural compounds, e.g. living organisms, which are capable of decay, and synthetic compounds, e.g. plastic, which may be biodegradable. Suspended solid. Solid in water may come from mining activity, river dredging, construction, e.g. road and bridge, and soil erosion. Nutrients. Nutrients, nitrogen, phosphorus, sulfur. In water encourage plant, usually in the form of algae. Those nutrients come from domestic, industrial, and agricultural waste. Diffuse pollution from agricultural waste is a major source of nutrients, especially nitrogen. Nutrient-enriched water is more productive with excessive biological activities, and water quality is usually significantly degraded, e.g. eutrophication. Thermal pollution. Industrial cooling process, e.g. fossil and nuclear power plants, discharge heated water into water bodies with effect on reduced solubility of oxygen and altered speed of chemical reaction. Thermal pollution changes the natural temperature relative of a water system, and the affected ecosystem could be stressed. Some aquatic species may die or are forced to relocate. Toxic metals. They are metals that form poisonous soluble compounds. Toxicity is linked with solubility and is directly proportional to its ability to cause environmental damage. Pathogen and carcinogens. Those are disease-causing microorganisms or cancer-causing substances, including bacteria, protozoa, dioxin, etc. Domestic wastewater is responsible for many of the pathogens, and industrial and agricultural wastes are the usual sources for carcinogens. Radioactive contamination. In the natural world, there is always radiation being emitted from radionuclides. Radioactive contamination refers to unintended or undesirable presence of radioactive substance in water, usually from the leakage of stored radioactive material or release from nuclear power plant accidents, etc. 7.2 Water pollution indicator. The indicators on water pollution are in three categories: physical, temperature, turbidity, total suspended or dissolved solid. Chemical, pH, dissolved oxygen, COD, BOD, pesticides, metals, and biological APT index, symbiotic index indicators. Most of them have been explained already in the book, and only a few indicators are further explained here. Oxygen saturation. The maximum amount of oxygen dissolved in water at a given temperature is called the saturation concentration. Biochemical oxygen demand (BOD) is the amount of oxygen required by microorganisms to break down in organic matters. It is used as an indicator of organic pollution of water. Chemical oxygen demand (COD) measures organic matters which are both biodegradable and non-biodegradable, hence it covers a more broad spectrum of organic matters. As a result, the COD in a water sample is always higher than BOD. Biological indicators are useful to get a general reading of water quality without the high cost of lab-scale analysis. Variables are used to represent the state of macroinvertebrates. They are in two types. 1. Pollution indices, existence or absence of indicator species. 2. Diversity indices to indicate the overall effect of all pollutants. However, biological indicators are not always reliable. Factors other than pollution can affect the biological indices. Absence of some species may reflect its normal life cycle, and quantitative sampling of biodiversity is difficult. 7.3 Wastewater treatment. Wastewater treatment plants receive inflows from domestic, commercial, agricultural, and industrial users, stormwater runoff, and infiltration. Industrial waste may contain heavy metal, radioactive material, refractory organic, which may be treated on site following specific guidelines. Domestic wastewater is commonly treated in municipal wastewater treatment plants. A main purpose for wastewater treatment is to control pollution of a receiving water body, river, lake, groundwater, sea. To design an effective treatment system, it is important to 1. Identify the characteristics of raw wastewater. 2. Set treatment objective. 3. Integrate unit treatment operation. 4. Assess the system in view of green engineering, life cycle thinking, and sustainability. The treatment unit include pre-treatment, primary treatment, secondary treatment, tertiary treatment, disinfection, sludge treatment. 7.4 Water quality modeling. Water quality models are used to analyze environmental system and predict water quality change due to modification in catchment and wastewater treatment plants. The prediction provides a basis for engineers to carry out economic analysis to evaluate various options to improve the environment. Water quality models are based on 1. The law of conservation of mass material transport into and out of the control volume as a physical process, and 2. The change of substance in the control volume transformation of the substances due to biological and or chemical process. Material transport refers to the movement of the substances from one point to another, which involves efficient movement with the fluid and diffusion or dispersion spread in the fluid due to differences in concentration. Following water quality models are widely used: aqueducts, basin, quality, sparrow, some, wasp. 7.5 Water quality standard for pollution management. Water pollution is usually managed by following water quality standard. Water quality standards are established by legal to define the level of pollutant allowed in a water system. There are three types of standard: the saving water standard and effluent standard. The saving water standard refers to water quality standard for receiving water bodies, rivers, lakes, seawaters, and effluent standard refers to the quality of effluents discharged to riverine water. The aim of both types of standard is to achieve the desired quality of a water system. The receiving water standard considers the use of the water system, swimming, irrigation, drinking industry. Effluent standard set the required maximum pollutant concentration to be achieved or degrees of treatment required before discharge. Both standards are regulated and should be met. Water quality standard must be reasonable so that discharge should be able to achieve the standard through the available technology. 8. Solid waste management. Solid wastes are defined as unused materials that are no longer of value to their owners, albeit they may be still of value to owner artists. They are generated from various human and animal activity. Each year, billions of tons of solid waste are generated which are in need of proper treatment. Improper management of solid waste has direct adverse effect on human health and the environment, e.g., polluting rivers and groundwater sources and generating foul air. 8.1 Sources and composition. The information on waste composition And generation rate is important for proper planning, treatment and disposal of solid waste. Some solid waste, e.g., industrial, agricultural, and mining, are managed by the waste producers. In this chapter, the focus is on the municipal solid waste (MCY), which include residential, commercial, institutional, construction, and demolition. Another way to classify waste is to divide them into biodegradable, spoiled food, green waste, recyclable, paper, glass bottle, cans, inert, construction and demolition waste, electrical and electronic, TV, computer, screens, etc. Composite waste clothing, Tetra Pak, waste plastics such as toys, hazardous paints, chemical, fluorescent tubes, spray cans, fertilizer, toxic, pesticide, herbicides, fungicides, medical, pharmaceutical drugs. Take 2 waste properties. Solid waste management option depend on physical and chemical characteristics of the waste. Waste generation rates are expressed in mass unit, e.g. kilogram or meter cubic, instead of volume unit. This because waste densities vary greatly among the waste with different compaction at different stages in the waste system: collection, storage, and disposal. The information on waste moisture content is used to derive dry mass of the received waste. In addition, for energy recovery design, it is important to know the energy content in waste. Plastic and paper have high energy content and low moisture content. In contrast, garden waste are less productive in energy release due to their high moisture content. 8.3 Solid waste system. 8.3.1 Stroke, collection and transport. This part of the waste system typically accounts for 40 to 80% of the total cost. For residential waste, the most common collection method is curbside. The wastes are usually segregated into different containers according to waste types: food, garden, waste, recyclable. 8.3.2 Recycling. Recycling is to convert waste into new product. It can reduce the consumption of fresh raw material. Recyclable material include glass, paper, metal, plastic, textile, and electronic. Energy usage, air pollution from incineration, and water pollution from landfill. 3.3 Composting. Composting is a microbial process used to treat biodegradable waste. It is similar to aerobic wastewater treatment. Composting has several purposes. 1. To reduce waste mass. 2. To reduce pollution potential. 3. To destroy pathogens. And 4. To produce compost as nutrients for garden, landscaping and agricultural organic farming. 834. Incineration. Incineration, waste to energy recovery, is a process to liberate the energy in waste by combustion. This is suitable for waste with high energy content, low moisture content, and low ash content, which include paper, plastic, textile, rubber, leather, and wood. Incineration produces two solid byproducts: bottom ash, unburned waste, and fly ash, suspended particulate matter. There are 6 commonly used in incineration system. 1. Mass burn for unsegregated solid waste. 2. Modular small incinerator for specific waste such as medical waste. 3. Refuse derived fuel energy-rich waste as fuel to power plant. 4. Co-incineration to combine with production waste. 5. Hazardous waste, pathogen and toxin destroyed by high temperature. And 6. Cement kilns as fuel for cement production. 835. Landfill. A landfill site is a site for the disposal of solid waste by burial. This is the oldest form of waste treatment and the most common method for waste disposal in many places of the world. In a landfill, waste are packed into solid form and covered to insulate them from weather and air. Usually every day with layers of soil. Leachate is a liquid drained from the landfill as a contaminated wastewater. In a new landfill with oxygen still available, organic matter decomposes and carbon dioxide is produced. As time goes by, the remaining oxygen is consumed and an anaerobic condition leads to the production of methane gas. 836. Alternative technology. In addition to the aforementioned traditional technology, many new approaches are undergoing development. They include aerobic digestion, alcohol or ethanol production, bio-drying, gasification, in-vessel composting, mechanical biological treatment, mechanical heat treatment, plasma arc waste disposal, pyrolysis, channel composting, USB applied to solid waste, and waste autoclave. 8.4. Solid waste management. The combination of different components should be considered as a whole in a holistic way to serve the needs of the current and future generation. Good policy should be developed by analyzing policy options with husband in costs and benefit, risks and unintended effect. The priority in a waste management policy is to reduce the waste and followed by reuse and recycle. The 3 Rs. The 3 Rs are expanded in Europe into a waste hierarchy: reduce, reuse, recycle, recovery, and disposal. 9. Air pollution. The air is surrounded by gas called air which form the atmosphere. The atmosphere is a complex, dynamic natural system essential to support life on the Earth. The air interacts with weather and land. Acid rain falling on the ground is a result of air pollution. Many pollutants, such as particulate matter, heavy metal, and ozone, are able to influence weather quality and ecosystem function. On the other hand, polluted river or lake and sewage system can cause air pollution in their surrounding areas. Therefore, it is important for a weather engineer to understand the air and its related quality issues and vice versa for an air quality engineer to understand weather pollution. 9.1 Composition of air. The composition of dry air is listed in table composition of dry air by NOAA 2012. This table changes with the time, e.g. CO2 concentration has been increased with time. Air also normally contains water vapor, variable about 1% mean 4% at surface. Dust, pollen, spores, sea, spray, volcanic ash, carbon dioxide, methane, nitrous oxide, and ozone. The air density at sea level is 1.2 kg or meter degree 3, and it decreases with the increasing height. 9.2 Structure of the atmosphere. The Earth's atmosphere has distinct layers with a total mass of 5×10 ranked 18 kg. 3/4 of which is within the bottom 11 km. The atmosphere becomes progressively thinner with altitude without a broad boundary. However, the Kármán line at 100 km above the Earth's sea level is commonly used as the boundary between the atmosphere and outer space. Beyond this altitude, the atmosphere becomes too thin to provide sufficient aerodynamic lift to support any aeronautical vessels within the orbital speed of the Earth. The atmosphere is divided into several layers based on temperature profile: troposphere, stratosphere, mesosphere, thermosphere. 9.3 Transport of air. The movement of air is divided into categories: the outdoor environment, ambient air, and indoor environment. Global transport. Among the layers of the atmosphere, the two layers near the Earth's surface are more relevant to air pollution. Regional transport. High and low air pressures dominate regional air transport. Local transport. Due to the different temperature between land and sea in the coastal area, the wind direction changes during the morning and evening. Indoor air. Indoor air quality has a significant impact on human health. Design of ventilation system in a building influences temperature, humidity, and pollen movement. 9.4 Air pollutant. Air pollutant is the introduction of a substance, i.e., pollutant in the air harmful to human and the environment which may be natural, e.g., volcano eruption or man-made. Pollutant can be solid, liquid, or gaseous. Major pollutants include nitrogen, dioxide, NO2, sulfur dioxide, SO2, particulate matter, PM, ground level ozone, O3, carbon monoxide. 9.5 Emission estimation and control. Emission is the amount of pollutant a source releases into the air. Emission rate is expressed as mass per time, such as G or S, kilogram or day, or tonnage or year. Emission rate and pollution composition can change with time. Air pollutants are sources from four main types. 1. Point source, a single identifiable source of air pollutant emission, such as a single furnace. 2. Line source, one-dimensional source of air pollutant emission, such as a line of vehicles on a road. 3. Area source, a two-dimensional source of diffuse air pollutant emission, such as forest fire and landfill. And 4. Volume source, a three-dimensional source of diffuse air pollutant emission, usually found in oil refineries. They may also be defined as stationary and mobile, e.g. cars. There are 5 methods to quantify air pollutant emission. 1. Direct measurement, either stationary sensor or mobile sensor. 2. Mass balance, an indirect way by the conservation of mass from the difference between the measured inflow and outflow in a system. 3. Process modeling, by mathematical modeling of physical and chemical process. 4. Emission factor modeling. Emission factor is the ratio of emission and pollutant source intensity and can be found in the published manual. The source intensity, such as kilogram or day, time is relevant emission factor to derive the estimate emission rate. 5. Expert judgment, subjective estimation by experience and knowledge. The reliability and cost are ranked from high to low with the method 1 to 5, i.e. method 1 is the most reliable and most costly, and method 5 is the least costly and least reliable. There are 5 options to control air pollution. 1. Prevention, green chemistry, green engineering. 2. Regulatory solution, permit for allowable emission monitoring. 3. Market solution, a total allowable emission cap is set and emission allowances can be traded in the market. 4. Voluntary solution, voluntary emission reduction by individual, communities, and firms encouraged by easy essays of air quality information. And 5. Emission control technology. Thermal oxidizer to oxide pollutant using high temperature in a similar way to incinerators. Absorption by passing polluted air through water-soluble media in a similar way to a smoking water pipe. Biofilter filled with a biological medium for the polluted air to be passed through to interact with the affected microorganisms and particulate emission control technology such as cyclone, scrubber, baghouse, and electrostatic precipitator. 9C. Air quality modeling and forecasting. Air quality is modeled by air dispersion model, also called atmospheric diffusion model, air quality model, or air pollution dispersion model. A set of many mathematical equations, physical and chemical process of air and its pollutant is solved by numerical methods on modern computer. The dispersion model is used to estimate or predict the downwind concentration of air pollutants emitted from various sources. Air dispersion models can be used by government agencies to determine whether an existing or new industrial plant will be compliant with the relevant air quality standard. They are also used by public safety organizations for air quality forecasting or scenario setting, which is important especially for emergency planning and operation of accidental chemical releases, e.g., evacuation or sheltering for persons in the downwind direction. A typical air dispersion model requires information on 1. Meteorological condition, wind speed and direction, atmospheric turbulence, ambient air temperature, the height to the bottom of any inversion aloft they may be present, cloud cover and solar radiation. 2. Pollutant source, the concentration of quantity of pollutant in emission or accident release, temperature or the material, source location and height, type of sources. 3. Terrain, elevation at the source location and at the receptor location. S. Land use or land cover information.